For the design document that I posted for you guys, this is not the complex design document that we use in industry. This is just a simple one for what we're going to be using for now. We're going to add a little more to it, but my advanced classes are the one that they're actually doing the design document, which is pages and pages of stuff. So we're just going to do something. The idea of design document is, let's say that you want to go camping or you want to go hiking. You just don't sit in your car and start driving and say, okay, I'm going to get to the camp sometime somewhere. You're going to think about it. It's okay, how do I get to the campsite? What do I need when I get there? Do I need a tent? Do I need some kind of oven type of thing or something that warm up stuff? Do I need a kettle? Do I need a pan? What do I need? So you're going to think about those things when you go hiking, or which route you're going to take to go for hiking. Where do you park your car? And if I'm going hiking, maybe I don't carry my whole heavy tent. So you're going to be doing all this thinking before you do it. Yes, of course, if I'm looking for something to eat today for lunch, I can sit in my car and drive around and maybe I find something. But if I think about it ahead of time and I said, what kind of food do I want? What, which one is the closest to my place or which one is the fanciest one, I can do some thinking or working before I go. So even with the small thing that I can do, sit in my car and drive around and find the restaurant, it's going to be a little more pleasant if I look for them, look at the rating, look at what kind of food do they have, atmosphere do they have before I get there. That way, even when it's taking me a little longer to get to the restaurant, it might not be what I was looking for. So I'm talking about all these things to bring this idea that when we write in code, we have to sit down and think about it before we actually write the code. So for those of you who are computer science major, you will take a software engineering course. I spent a lot of time in software engineering because I was very, very interested in it. And some of the company I got in there, they had some things in place for training and those kind of things. So it's a very, very good thing to know. And if you're really doing a good, solid program in industry, you spend 60-70% of the time designing it, and 30% of time you actually writing the code. You might not even write the code because it's much cheaper to send it overseas to write the code. I mean, I had this experience that here we were hiring people at that time. God, what was that, like 20 years ago? $130 per hour for a software engineer to write the code for us. And then we would send it to India for a company that was charging us $12 per hour. So that's one of the reasons they were sending all this stuff in there. And we knew that they're going to cheat us a little bit, but even if we take that software and give it to two different companies to be sure that we get what we want, it still was $24 per hour. I was working in Alpine Electronic. We had 100 engineers over here in Torrance. We were doing the early GPS for Honda, Jaguar, was it Mercedes in there too? So it was few cars who were doing it. And they went to China. They opened up much bigger place with 300 engineers, including some with PhDs and those kind of things. And that was like a half of cost that we have here in Torrance. So that's the reason some of the things are going there. I'm not trying to scare you guys or anything like that, but sometimes the cost effective. So the creating a design is very, very important. Even if I'm just a coder, I'm not a designer, understanding the software design, it is helping me to write a much better code. So that's what we're going to go forward. All right, so let's go jump in this. I am talking about input, processing, output. And I throw out these variables because I wanted you guys to think about it before you start your program. So you can download this document and start typing in there. You don't have to make your own document. So you can just take this one as a template and just answer each one of them in the document. And you might want to keep a template of it so for the next assignment. So every problem you do, you need one of these attached to it. So when you have two problems in your assignment, you're going to have two design documents, two coding. When you have two problems in your lab, you have two design documents and two coding. I most likely going to be, I'm still trying to find time to do your test grading, and we're going to see how far we're going to go. But these are some of the things I'm going to be checking, and be sure you do the same when you do the peer review with your classmates. So the idea is we're going to be thinking about this. Okay. So first thing first, so when we're talking about this in industry, this is IPO, input processing output. So this is something that I learned a long time ago, 34 years ago, and that's just a basic, simple way. What is coming into my program? What is my program doing? What is coming out of my program? Just like in manufacturing. We're getting a raw material coming to manufacturing, they process that raw material, they have a finished product that's going out of the manufacturer. Okay, so let's talk about the input. So the input is what is coming into my program, what comes to my program. So in detail, I'm gonna define what's coming into my program. And the next question is, how do we validate the input? First of all, the computer doesn't have unlimited space. So when we're writing the program, we have to have some kind of a limit for everything that we are using. So we're going to practice this. Of course, in some rare cases, we might not be able to do it, but in general, we should know some kind of a limit for everything that comes in. So for few reasons, one of the most important reasons that we want to do this is if the data is bad, I shouldn't be going and do the whole program with a bad data. For example, I'm going to be asking age. I don't know what the range of age is, but if somebody put 150 for age, that is wrong. So I have to catch it and say, hey, you gave me a wrong age. Would you please give me another one? So that's what we're doing the validation. And I want you guys pay attention to that and think about it a little more. That if I'm doing this, I have to figure out what we're talking about. That's for validation. And the pseudocode is you briefly explain in English what are you doing. So you can mix up some code in there, but the whole idea of the design document is we are not thinking about coding while we're doing the design. You are not going to open your IDE. You don't even think about coding. It is very hard for some of us that learn how to code before we do designing. So a typical example is when we are talking to the customer and the customer is telling us what they want. I am thinking about my coding. So the first thing I do is what? I stop listening to the customer because I'm thinking about the code. And the customer is saying things I'm not even listening. So it is very, very important to separate these two and focus on each one of these at a time. So we're focusing on one thing at a time. You don't jump around. I do that, but I'm trying to control it. So we stay with one thing at a time. In 3.3 part 1, I am talking about the validation. In 3.2 part 1, I'm talking about the pseudocode. So those are the video lectures out there. I'm hoping that some of you have looked at those things, at least to give me some incentive to do more of those. Because if nobody's looking at it, what should I do it, huh? So if you have not watched them, we're going to go over them and I'm going to be sure we understand it. If we don't have no idea what the validation is, we cannot validate, we cannot use it. If we don't know what the pseudocode is, we cannot use it. So a pseudocode for my input can be something like this. So I'm asking the user to enter age between 16 and 99. So I'm going to prompt for the user to do that. I'm going to read age. And then if the age is not in between 16 and 99, I have to ask myself, am I including 16 and 99, or I'm going to exclude 16 and 99? So that's something that I have to think about it. And so if it's not, I'm going to display an error message. Excuse me. And then I'm going to prompt the user again. I'm going to read the age again. And if it's not correct, I'm going to do this. So I'm going to loop here till I get the correct answer. So Tesla Manufacturing requested aluminum as a raw material to create an aluminum cast for part of the car. So instead of aluminum, if they send some other metal, they're not going to go build a car with the car. They said this is not a correct product, or even the aluminum with certain gauge. So they send it back. And if they bring the wrong material again, they're going to send it back. They're not going to use it in their production till they be sure they have the correct input, correct raw material. So that's the part for the input. Then for the processing part, we're going to take that raw data and we're going to do something. So the question that we're going to be asking is, what does this program calculate? So this one, the answer of this is going to go on top of your program in the comment. Remember, we are following the style in section 2.5. I urge you to go and read 2.5 again and apply everything that's in 2.5 in your program. That's going to be writing good code versus writing sloppy code. That's why computer science software engineers get more money than just the programmer, because you know this stuff. The next question is, can we divide to this smaller module? The idea here is, if we are doing something and this doing something, we can break it down to the smaller pieces. Let's do that and focus on one piece at a time instead of thinking about the whole thing. So you see that you do that in your calculus class, you do it in other places, that when you want to solve a problem, even in the real life, if I have a complex problem, what I'm going to do, I'm going to break it down to the smaller problems. I fix those or solve the smaller one, then I go to the bigger one. I'm not thinking about that. And that's sometimes when people get frustrated, they're looking at some complex thing and they think, okay, I cannot do it, so they leave it. So you're here, you want to get your bachelor's degree, let's say in computer science, and some people think about it, oh, I got to go all this many years to school to get a bachelor, that's too much, I'm not going to do it. And some people are just focusing, okay, let's focus on this semester. I'm going to be passing these courses right now. And then when I pass these courses, I'm going to go take other courses. And then I put all of these things. Then I have my bachelor degree. So we got to break it down to the smaller piece. Do the smaller more pieces first, and then we're going to put it back together. And then we're going to be writing, of course, the pseudocode for these things. So technically, if I do these things correctly, and I take the pseudocode to write the code for it, it should not take more than 10 minutes to do. Because I did all my thinking over here, and my pseudocode is going to direct me what they need to do. I just take the pseudocode and change it to code. I can send it to anybody to do it. And the key for that is what? The pseudocode is not language dependent. So if the language is not important to me, I send it to India. They want to write it in Visual Studio. I send it to China. They want to write it in Java. I send it to Philippines. They want to write it in Python. So I am okay with anybody want to write it in any language. So my pseudocode is not language dependent. So in this case, I'm doing the sum. I want to do the average. So I am calculating the average. So this program calculates average. I'm going to take this one and put it on top of my program in the comment. And this one still is a little vague. When you say average, average of what? Am I averaging some temperature? Am I averaging some grades? What is it that the average is about? So I have to be a little more detailed on these, and then I take it and put it up there. So when I want to do average, I have to take a sum, and then I have to divide it with how many numbers do I have. So one of the things that you worked on in last chapter was asking for 10 numbers. And you did the positive, negative on it. But let's say in this case, they say, okay, the problem is ask user up to 10 times for a positive number. And if the person enters negative, you stop. Okay, so I'm going to create a loop for 10 times. I'm thinking about this. I'm going to write it down and I'm going to go over it again. Especially when you're working with a team, you got to go back and forth. You got to work with this together. You should not say, okay, you go to this one, I'll go to this one. You have to work together to understand this. So I'm more critical about your design document in the lab than I'm in the individual ones. And you both are responsible for it. So if I see something wrong and I point for you or I confront you, you cannot tell me that my partner did this, I don't know. That's not acceptable. Something goes wrong with the lab assignment, everybody in the lab assignment is responsible. So we do the loop for 10 times. We're going to ask the user for a number. Remember, I'm going to do the sum first, and then I'm going to do the average. So I'm going to ask the user for a number. When I get the number, I'm going to add it to my sum. I'm going to check it to see if it's positive. If it's positive, I'm going to ask it to add it to my total or sum. If it's not positive, I'm going to break. Remember, break is going to take you out of the loop. So I'm going to break out of the loop. Now, when I get after the loop, I'm going to divide by number. But now I notice that, wait a minute, not every user is going to put 10 numbers. Even though my loop is 10, I can potentially break out of this loop. So I need to know how many numbers did the user put. So what do? I go and add an extra line to have a counter or something to check to see how many numbers do I have. So this way, when I go out of the loop, I'm going to have some kind of a number of elements. So I know if they did 2, 5, definitely they cannot go more than 10. The maximum is 10. So, but they can have anything in that area. Remember the word break. So we have break versus continue. Break is going to take you out of the loop. Continue is going to take you back to the top of the loop. So continue is going to bring me back to here, but the break is going to take me out of the loop. So keep those in mind, especially for your switch statement. Now that I know how many numbers do I have, I'm going to be doing the next one, calculating the average. So I'm going to take the total or sum that I created over here. I'm going to divide it by the number. Now, whenever I do the divide, I'm going to think about it. Okay, is it possible that I'm going to be dividing by 0? So I'm going to go back and think about it. See, I am doing all my thinking over here. I'm not doing my thinking while I'm writing code, because that's two things I'm trying to do at the same time, and I might get myself confused. So is it possible for numbers, how many numbers I have is 0. So I go back, I'm asking the user to enter a number. And if it's a negative, it's going to get out of this loop. What about the first number that the user puts is a negative number? Then the number, how many numbers is going to be 0. And if it's 0, I'm dividing by 0. So I have to put a catch on that. So I have to fix that. I have to worry about that. Remember when we talked about the and, again, watch those videos. I try to make it shorter so it's not a long video. Hopefully you guys are watching those. So with the and section is talking about how to catch something through the and part. So you can check to see if this number is 0, and then you're going to do the calculation. Any questions so far?
Yeah, I have a question.
Sure.
I was actually earlier about input validation. Is there a way like in this chapter to check for type, or is that something that's going to be down the line?
We're going to be talking about that in chapter 6.
Okay, cool.
But if you are interested, we can individually work on it, but it is something that's coming up later.
Okay, thank you.
You're welcome. Okay, so I have another pseudocode over here. You can see that the pseudocode is not the actual code, but in this case, we are looking at some if here. So we have the if, we are doing some indentation to kind of look like a code, but it's not actually the whole code. It's just talking about some stuff. And definitely when I see something like this and I see 3/4, 3 divided by 4 is what?
It's a
Huh?
0.75?
No. I'm talking about C++. I'm not talking about math.
Is that 0.75?
No.
Zero?
A floating
0.
point.
Integer divided by integer is integer. 3 divided by 4 is 0. So we're going to be careful every time we have 1 divided by 4 is 0. So both of these are going to be 0. 3% 4 is going to give you 3. That's the remainder. But the division is 0. So we got to practice on those things to be sure that we don't put those in our program. Any other questions? Okay, the next section is going to be the output. So what is the finished product in my work? What is going to be coming out of my work? So what is it that user is going to see? And then what kind of a formatting do we need? Do we put a $sign on it? Do we put some decimal point on it? And of course, we're going to just have a pseudocode for it. So for example, I'm going to be displaying something like this. Net income equal $sign. So I'm making it user friendly. Remember, if the user is not happy with our program, what's going to happen? Either they're not going to use it or they're going to use it with some resistance. Eventually, our program is going to be useless. I was working with some hospital programs and all those things. And I was talking to some nurses, and the head nurse was saying that nobody's using this new program, that they spent so much money to bring it in because of the way it looks compared to what they are used to and compared to the things that they want to do it. So practically they went out there, they paid all this money, and the company has spent so much time to create this wonderful program, but nobody's using it. So that is not what we want. We want to be sure our program is user-friendly. So that's one of the concerns that we have. We're going to be talking, we did talk about how we're going to format the decimal points. So we're going to be putting it in the output section. So I generally start with this one right here. So I'm going to say, what is it that my user is going to be looking at? What is it that I want the user to see? So I'm going to say your net income is 65,000 with a $sign. So I need to have a $sign. And then I ask the question, does it have to be 65,000 or it's going to be 65,000.00? Remember, in US currency has 2 decimal points. So maybe I want to make this 65,000 to 65,000.00. Now, On the other side of it, it can be that companies like IRS doesn't want to bother with the decimal point. So if it has a decimal point, I have to use this to calculate the precision. But what about if it doesn't have decimal point? How do I get a decimal point away from my double? So if I have a double, let's say my net income is 65,000.0. How do I make that 65,000 with no point? How do I make a program? How do I make this variable to have no decimal point?
Where it says precision
Okay, one way is to make the precision
with zero.
zero. But remember, when you do that, you have in here show point. Then it's going to show you 65,000.0.
Can you change the double to integer?
Good. So if you take your double, assign it to an integer variable, that integer variable is going to get rid of your decimal point. So I don't even have to worry about it anymore. I'm going to take my double and I'm going to force it into the integer. My integer doesn't have no decimal point anymore. I don't even have to use this formatting. If that's the case, we got to decide what is it going to be doing. So we're going to display a message of what we want to display. So a typical programmer does what, especially when we're starting. So you run the program and it shows 65,000 right there on the screen. And the user is, okay, what is this 65,000? So we have to say, this is your net income, or we have to have some verbiage. We have to make our program user friendly. So when they look at it, they know what we're talking about. Sometimes we add some more stuff in it. So if I am talking about tax, for example, I'm going to say, okay, this is your salary you gave me. This is the tax rate, and this is what we are talking about the tax. So I'm giving them some more formatting or some more additional stuff. So they look at it and say, wait a minute, I did a mistake. You are calculating tax based on 65,000, but I meant to put 60,000 or 75,000. So they're going to run the program again, put the correct one. But we have to put those things to be more user friendly. Okie doke, questions. So that's the output. The last thing we want to do, and throw this in there, was not part of the original one, but I want to think about the variables. So we got some variable coming in from the input, we got some variable coming in from our processing, and we want to think about those variables. What are they? Or am I doing? So I am. So when I have the variable, are they having a good names? I am not very good in coming up with good names, but we're going to be practicing. I'm going to do it. There is no single character variable names in your programs. You're going to have some special cases, but the goal is you are not going to have single character variable names. And your book decided to use camel case, which is nice and clean, in 10th edition. So if you're looking at the previous versions, it's not using camel case. And that's basically my life. I'm used to the underscore, and I changed to camel case, and you can see me going back and forth. But you know, if you're familiar with Java language, they use the camel case all over the place. Now, remember about the numbers in your program. You're going to create constants for all the numbers that you have in your program. And constant has to be all uppercase. So we're going to be forced to use underscore for the constants. Then we're going to ask the question that if the user asks to run the program again, what is it that we're going to be resetting? Remember, most of your variables are outside of your loop. We can potentially put it in a loop, but if you need it somewhere else, it has to be outside. So the question is, do we need to reset anything? So in my sum example or total, I was adding a number to my total. And if I run the program again, my total has some value from the previous program, and then I add to that total. So I have to reset my total. But the average, I'm calculating the average. So it doesn't matter what it has because it's on the left side, then it's going to be put the new value on it. So a rule of thumb is if I have things on the right-hand side, they have to be either reset or be read from the user, getting a new value. If they are in the left side, I don't have to worry about it. So my average was saying that sum divided by total numbers that I use, or number of how many numbers did I have. So how many numbers do I have is coming from my loop, so I don't have to reset that. I'm talking about the right side. And total has to be reset otherwise. And the average, because it's on the left side, I don't have to reset it. So the bottom line in this section is that no magic number. What does no magic number mean?